You've completed the assembly on your digital dial and it doesn't appear to work right, so let's take some typical troubleshooting steps. First thing you want to do is make sure you have power here, 9 volts to 12 volts or so it says. And next check I would make would be over here on pin 3, which is the output of the 5 volt regulator. We should have 5 volts DC here. If we don't, you may have installed the diode backwards. The way to test for that is to test to see if you have your applied voltage here on pin 1. From that point, I'd move over to the JFET. The 5 volts is tied right to here, and here we have our input from the signal generator or whatever you're using to test it. So we want to have maybe around a half volt to a volt there. Should be fine. We can look down here and we should have about the same here, because this is set up as a source follower. So all we're doing is given a high input impedance here, so you got about 1 megohm input impedance, and we have about 2.2K here to drive the transistor with. So if we have our same level of signal here as we had in, the JFET's working. If you don't, what you could check for is to make sure you have it in right side up. I put mine in upside down twice, so it's an easy thing to do. The next thing you can check is down here on the collector of Q2. If you check the basic Q2, you ought to have a DC voltage there. You ought to have around 6/7 of a volt, because it's just the emitter is tied to ground. So if we have 6 or 7/10 of a volt DC here on the base, it's forward biased. If you have 5 volts there, you're either have an open emitter solder joint on the transistor, or the base emitter junction on the transistor is open. So we'll assume that that's working, and we'll go on to the collector of Q2, and you should have a couple volts signal out here on the collector of Q2. So if you don't have that, Q2 may be bad. If you've got it there, the next step I would do is go down here to pin 13 on the decade divider. If you have it there, about the only thing you have left to do is check up here on pin 16 to make sure you have the 5 volts. Check to make sure you've got ground down here on pin 8. You should also have ground down here on pin 15. If those are all okay, and we should also have 5 volts down here on pin 14. If those are all okay, the divider just about has to be bad. You don't want that to be the case, because that's going to be a lot more trouble to remove from the circuit. Probably the easiest way to remove one of these from the circuit, if you know it's bad, is take a sharp pair of dikes and clip the leads right next to the body, so that you remove the whole IC plastic body, then come back and remove the leads one at a time. That's a destructive removal though, so you need to make sure that it's bad before you do that. So if you've got the input to the counter going, it's a divide by 10, you should get 1/10 the frequency out here. So if you get that, it almost puts it back up into the microcontroller. If you're getting the divide by 10 out of the divide by 10 IC, next thing I would check would be up here on a 10 meg oscillator. You should be able to use your scope and look at it and see if it's oscillating. If it's oscillating, or if it's not oscillating, the next thing to do is check the power on the tiny 2313. So let's take a look at, if we look close, our power comes in here, goes over here to the anode of the diode here. This is the cathode of the diode. and here's our three-terminal voltage regulator. So power's coming in right here. This is ground, and this should be 5 volts out. So we'll just take and we can measure both places. We'll just measure here to make sure we have our 10 or 12 volts in and that we have 5 volts out. Once we have that, then we can proceed on. If you use your magnifier, you'll find that this is the emitter of the emitter. Yeah, it's not a transistor. This would be the source. This would be the drain over here. This would be the gate, and you can trace it out on the circuit board itself. Easiest place to check for the collector of Q2 is going to be up here on the lead on L1. Just be careful when you're probing these not to short things out. The other place you could check instead of here for the output of Q2 would be up on pin 13 of U2. So if we've got signal in those places, we want to check the output on pin 12 of U2. I'm talking about checking on U2 and U1, and the references I was given was using the schematic. It's on page 12 in the assembly manual. I just noticed that U1 here is the 74HC017, so that's labeled as U2 in the schematic. So they're reversed. It's not, there's not much chance you're going to get U1 and U2 mixed up, because the processor has got 20 pins and U1 has 16 pins. So you just have to cross out the U2 U1 reference in the schematic and reverse them. Now when you're probing one of these, you want to be extremely careful, because it's easy to slip between the pins with the probe, especially if you've got a larger probe, and short the pins out. And if you do that, you stand a real good chance of harming a component. The other thing I wanted to mention on this is, I didn't in the assembly, but if you look closely here at the IC, there is actually no pin 1 indicator. Normally this is pin 1. Normally it would have a little dimple or a notch or something, but on this particular surface mount device, this bevel right here on this side, it's got a large bevel on the side that goes down towards U1. So if you look at the big bevel, you notice it's not beveled the same on this side. If you look at the bevel, place that bevel down, then pin 1 is on the left hand side here. We're going to check the power readings first. We'll check the applied voltage first. We're going to read some voltages now. I did this once, filmed it, run it into the editor, and the voltmeter was upside down. So rather than ask you to turn your TV upside down for this little section, or your computer monitor, I'll redo these. We're going to start out right with the input voltage. I have 9.65 volts applied. We're going to follow that on down through in to the opposite side of the diode. On the opposite side of the diode we have 9.37, so we got about 0.3 volt drop across the diode. That goes on into the 3-terminal regulator. Here's the input to the 3-terminal regulator. Here's the output of the 3-terminal regulator. So we get 4.94 volts VCC. That goes down to the 2 ICs. We'll check power on the ICs. Pin 20 on the 20 pin is power. I have power there. On the 16 pin, power is pin 16. We have power there. So we have power everywhere that requires it. And I go down and check on the JFET, being careful not to short anything out. We have power. Okay, we're hooked up to the input line, so we have just a little over a half a volt going in. Sweep speed's 100 nanoseconds per division, so that works out, shows we have 10 megahertz input. So let's go ahead and take a look at the output of the JFET. We should have almost the same voltage coming out of it as we have going into it. Here's the output. We have just a little less than 500 millivolts. We lost a little signal. Now it's a little bit distorted because what's happening is when it goes positive, it's turning on the base emitter junction of Q2. So we're looking right across the diode junction with the output of that. So let's go ahead and look at the output of Q2. Like I said earlier, the easiest place to do this is up on the inductor. It's quite a bit larger. In fact, we're going to have to change it. Divisions. And now we have 2 volts per division. And I keep slipping off. We have 2 volts per division, so we're getting 5 volts out. Which that makes sense to me because that transistor is set up for a lot of gain, and it actually runs into saturation because the emitter is tied to ground, so there's very little emitter resistance, and the collector resistance has a 1K resistor in there, so it would have a gain of 100 or well over 100, I would guess. So it's driving it into saturation and cutoff. So that's not a problem though, because we're going to just count that. So let's take a look. That's going out of Q2, it goes into pin 13 on the decade divider. Pin 13 is the input on the decade divider, and it's the same level. It should be, because it was just a direct circuit board trace. The output is coming out on pin 12. It should be 1/10 the frequency. And there we go. It's divided it by 10. Before we had a cycle every 100 nanoseconds. So let's go ahead and change the sweep speed. Now we have a cycle every 1 microsecond. So that's working great. That goes up and goes into the processor. So we really can't check anything up there other than for the oscillator. But we can go look at the oscillator. Oscillator is tied across pin 5 and pin 6, so we should be able to look at that. It's supposed to be 10 megahertz, so we can readjust the sweep speed. 100 nanoseconds, we have 1 cycle per division, so it's running at 10 megahertz, so we're fine. I'm on pin 5 here. It's a nice looking sine wave. So it looks like everything's working. Let's take a look and see if it really is. So we got powered up, and dang it, it's not working. Reads all zeros. Oh, wait just a second here. It reads that because it's measuring 10 megahertz. Let's change the frequency. We'll go to 10.1. Hey, looks great. 10.2. 14.2 megahertz. Reads 14.2. Reads 200 kilohertz. That's the expanded mode. So it's reading over here on this side. This is 100 hertz increments. We can test that. We'll go up 100 hertz, and there it is. There's 14.2008 coming in. It works great. Let's hook it up to the BitX now and see how that works.
Well, not much. I just got around to put the contest amplifier in line. You know, I put all these cables in, and you know, there's all kind of plugs or connectors, you know, so I can
I'm at 14.181. I'm just reading the VFO right now. I haven't hooked it up to the VFO to calibrate it. So but I'm running a 10 megahertz IF here, so I'd be at 14.180.
Between 15 and 20 dBs over S9, so that's a pretty good one. You're the same, 15 to 20 over 9. Beautiful signal. Okay, well, see you later.
Take care. Say hi to the kids and your wife, and I'll chat with you later. DF2PYW6LG. Bye-bye.
Yeah, okay. We're finally got all the alt flooring in the living room done.
Works great, be able to just read your frequency off the dial. With this particular setup I have with the 10-turn pot running varactor, I can run up to 14.402 on the high end. Then on the low end, I can go down to 14.107. Little data activity today.
Back to Florida, you are a little lower, but you are okay. There's no problem cutting. I did not hear another station yet, but it looks like the propagation is okay. Detroit.
I'm going to pronounce this a success, and next step is to modify it to where I can cut the chassis and mount it in the chassis, and it'll be a completed project. Good luck on your digital dial if you're building one. I had a great time with mine, and hope you had as good a success with yours as I did on mine.